the stream. Oh, how I did this. I selected these faces. And then there's this special thing. I love this functionality of low polys things. Dissolve faces. And then it keeps that versus, let's say we started anew. I wanted to hook up the camera or something. Because a lot of times intuition will kind of trick you into doing this. Separate. So that problem is a this'er. Yeah, maybe you do want that. I don't know. But if you do want that, you kept the other one. Say it was here, so we could see. And if we did it again, oh, whoops, it's selected. Yeah, selected. Dissolve. Yeah, so now we get that. Yeah, Blender typology. Now we can make a matryoshka. Cool. Yeah, okay. Back to Vulkan Land. So in Vulkan Land, where's the book? We were on interfaces. I want to do a little tutorial today, not too much. This is just basically a rehash. Alright, so this is our device. Now I've tried to get the device in different scenarios. So for example, Windows 10, low SDK 2012 Visual Studio. Is this the one? Yeah. So this is failure at its finest. And let's say we had like, it's an interesting project because here I'm just using Windows lean and mean. And I have a few of these lean and mean projects where I'm trying to do different things with the COM objects. Yeah, like we're doing like SQL into the operating system. Yeah, because the Windows backend operating system is just MS SQL, essentially. And guess what? This doesn't work. I made the AI write this, obviously, but I had to pat it down, help it, and fix it. And still, I wasn't able to distill the VRAM. Like, because I know that this video card has 4 gigs of VRAM. And it's an interesting card. It's an AMD Radeon HD 7600 series, which is a pretty dusty card, but it's still kind of newish. It's right at that millennia when before the 8 giggers and all the nice. It failed again. Fuck. Yeah, I'm trying to copy over source SDK, and the way I'm doing, I should be using. I need to install FTP. Not Qt FTP, the FileZilla server, and do it that way. It's the best way to transfer files. It's the old school way of transferring files without using GitHub. Like, I'm trying to avoid having this GitHub. Okay, and so when we ran this, we just didn't get, okay, yeah, so it gets the adapter like that, but it still can't see what the VRAM is. So this is like an issue of epic proportions, because when you're getting the device and you're getting ready to run Vulkan, the most important thing is you're like doing a video card driver essentially. So you have to like care. Oh yeah, about the video card, the side note. The side note is The interesting part is I want this video card to like mine Bitcoin or do OpenCL for bots or trade LLM text-to-text chatbot or some sort of other consortium of massive fluid armies of stuff. So when you look up this card, it gives you the wrong card. It gives you the new card. It gives you this one. So I'm guessing this is its a little brother. That's like, and this one's pretty beefy. It's like your standard slug, I call them. 8 gigs is your standard amount. This is almost sort of what I bought. I only bought like the 6000 series. This is 6000 series is supported by Mac OS. It's a little older, but, and so this card, it's pretty beefy. Like, it can do things. But it's not the card we're talking about. The one we're really talking about is something like this. Yeah, it has like 2 DVI ports. I think it's this one. It's called Southern Islands. What a name. Okay. And we are dealing with something like probably 7670 multi-monitor support. So it's like it's kind of a good card. Yeah, OpenCL 1.0 to 1.2 are supported for all these chips with Terascale and GCN architecture. So it means it can do basically compute. Vulkan 1.1 is supported. Vulkan 1.2 is available with Windows and internal and newer. Vulkan 3 is available. So interesting, right? Not 1.4 though. So it can do it. It can do it, and yeah, we see kind of this. This just basically means the thing is a fucking machine. If it's making that much heat, it must be doing stuff. And the chips haven't really changed even nowadays. This is just an older version. And why are we looking at Radeons? Because the guy that makes NVIDIA and the lady that makes AMD are practically family members. So their science degrees are probably at similar capacity. As you could see, OpenCL is just basically OpenGL in my opinion. It's the same thing. Close to metal OpenCL. Yeah, it's just, so it's like what? Yeah, so Radeon HD 6000 is when you get kind of good. 2010. Yeah, so we're kind of studying the whole instance and device. Step number 1 and step number 2 in Vulkan here. Kind of my nerd consortium. See, it's available on Linux, no image support on Clover with RustCL. That means Mac OS, blah, 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 blah. Long story short, good luck getting that to work. And ROCM driver will probably not be available on it. I see it go down this, and I don't see this on here. Damn it, it misses. Okay. It misses the ROCM driver just by a slither, just by one generation of 2 years. And it kind of doesn't, and it does, because you see that 7000 is right here. All right. Let's see. Utils copied. And we need to copy tier 1. Tier 1 is like really important. I'll have a lot of fun reassembling the compilation of the source code, but did I download the book? Yeah, okay. Okay, let's go. It's an ebook. I don't know. I found it somewhere. So, presentation, queues and devices. We need to look at instances, devices, and queues. Introduction. Overview of Vulkan. What you'll learn in this chapter, Vulkan and its fundamentals results, how to get a minimal Vulkan application, the terminology and concepts in the remainder of this book. Vulkan is a program interface compute devices, so that's important because we can use the compute architecture to sit there in the background and generate our post-processing shaders with basically our JPEGs and our in-memory array buffers, or as they call them on OpenGL, frame buffers. And frame buffers in Vulkan, I guess, are different than frame buffers in OpenGL. I think the main difference is that the capability of the abstraction of the graphics layer, which just basically means you just get more control inside the graphics card, which is why you have to have these objects you're managing. I guess that's my opinion, but in reality, that's what I would want it to do, at least. Because when you deal with stuff like Raspberry Pi and you just have this very limited environment, you learn a lot of this. You're like, oh, the most I can do is instancing through a texture, because that way I can allocate and do voxel and make Minecraft work. And Minecraft works very well on Raspberry Pi Zero, surprisingly. It's smooth. You can play it. It's playable. But is it that version with Java and all these add-ons and mods? No. You would have to kind of do it yourself. But it's already compiled and comes on the device pre-baked for you. So you just like play it out of the box, and I can play it on this little controller thinger. Where's the Camouflage Studio? Camouflage Studio. So yeah, we were doing this yesterday. BK create instance function with the BK results. So my problem was I wasn't really caring about the result. Uh-oh, I clicked on something and it took me to informit.com. I guess this is where you can get the book. And at the back, there's a code snippet. And these code snippets are kind of trashy. Okay, so this is how they do it. They suggest we write this code. Can we copy paste this into our thing? They write in C++, BK result, BK app, : init, BK result equals BK success, assume succession, BK application info, app info, parentheses around : instance create info, instance generic application infrastructure. This is sort of what setting up basic Windows or something. Copy paste this into our longing dusty project already. It's getting dusty already. It's been a day. And then let's set a startup. So here we have some other notes from the specs. We would still need to rewrite this function. Physical devices. I think enumerate physical devices. Yeah, he starts to initialize. So I'm just trying to do create instance. So if we BK result. So let's say. I was trying to. Put BK result up in the file for now. Because when we call return, we don't want to return BK result. We'll call BK result instance equals success equals true up top, and then we'll set it inside the function. Now what I wanted to do was what the other guy that's doing a Vulkan C tutorial was trying to avoid is things like goto statements. Goto statements are really fast. They are faster than pushing and popping. They are just like if you program assembly, you love them, or you like want to get away out of them. Then you're sitting there debugging what's in the register instead of what's in the variable. What's in the variable, it gets pushed onto the heap or data or whatever stack, and then you go. Yeah, it gets read. Memory has to be read in and out. When it stays in CPU, your code offset segment thing, register, just changes on go-to statement. You don't have to change the variable. It's like really fast. You basically, like, you don't notice the speed, but your CPU produced like a nanometer or less heat, and that's where all your power is. It's like not wasting a single electron. The more electrons you save, the longer your players are going to be able to play a crazy RTS with a bunch of stupid stuff, even on little things. So imagine you have these like dinosaur laptops out of the junkyard or machines from HP, recycled, onboard GPU, everything sucks. And those machines will love you for it. They're like, oh, with our broken fans and no airflow, we don't get heat? Oh, okay. You can keep running this. That's how IT works. Or it doesn't work. I mean, it works because job security. It's like everybody wants to have that cheap computer. Alright, so once we got this result, that's the problem I don't like about this. It assumes that the result is true. And let's declare this. What if we say success is 0 and failure is 1, right? What about -1? Well, we know the function will be done, so we will put something in there. Okay, I have to use logic here. The next thing will be instantiating device. What does that do? If this is true, enumerate devices, physical count, if VK success, size device array appropriate, get physical device handle. What a stupid way of doing this. Well, it's a newbie Vulkan book. What can I say? It does a little better job of some of the AI generated code I've seen for this. We'll copy this for now. Start shoveling this into here. We're not really creating a device, we're actually selecting one out. M instance. What is M instance? It's something to do with instance. M instance, physical device count. M instance is what we got back from instance. How did they make this? Okay, this is how they set application info. I did a mem copy. Now, I believe my solution is correct. This is how they did. They created the Vulkan instance info. It's going to be called that. So that's another way of doing it. Instead of, oh, this is how I do it. This is the equivalence. Like which one's better, memset or this evil-looking C++ thing? I like mine better, but we can leave that here. So later we could just trace through it and debug it and see what it's getting. This is really what we need to be saving. Okay, so it passes in as a reference. So we get it back. So we need the SPK instance inside create device. Let's pass that in. Let's call it an instance. Alright, I'll stream later. I don't want to get too into this. Okay, so this is kind of the flow. Create device. It's like VK create device. It's like the next. Yeah, device properties. We could like dump them out. There is like callbacks to do this and better. Because I'm interested in this device if I could get the memory size. Get memory size, that'll be my side note. And then get the displays count, and then get device used for display. So if you have an onboard, here's what I wanted to do also. Use the onboard as a mini compute engine. And have a setting to where you can disable that, because like, let's say you know your onboard is garbage and there's something wrong, like not enough heating, or you want your laptop to run your GPU while it's processing LLM stuff, or use that for the NPCs, or you want to disable that because you don't waste power or something, or some other reason, like the GPU is doing Bitcoin mining while you're, or training a neural network while you're playing a game, so you could use the proper GPU, because that's the whole point of this. It's control over your devices, kind of customized. And if you don't care and you're dumb, it'll just try to use the best thing. And that's usually what there's like 3 different goals.